Find the image of the point 2, 3 under the following transformations. The first one is S sub x. Now this means axial symmetry in the x-axis. So here is the point 2, 3. We want to get the image of it under axial symmetry in the x-axis. We can think of the x-axis as being a mirror, and here's an object above the mirror, and its image is the same distance behind the mirror as the object is above the mirror. So we can see that the object is the point is 3 units above the x-axis, so its image will be 3 units below the x-axis. So its image is going to be 2, minus 3. So to get the image of a point under axial symmetry in a line, we just move through the line at right angles, and we go out the same distance on the other side. So basically what happens is the y value of the point changes sign, and the x value remains the same. So under symmetry in the x-axis, 2, 3 becomes 2 minus 3. Now let's look at the image of 2, 3 under axial symmetry in the y-axis. That's sy. So similarly, like to before, we just map the point through the y-axis. So we go through the y-axis at right angles and go out the same distance on the other side. So we're 2 units. This point is 2 units to the right of the y-axis, so the image is 2 units to the left of the y-axis. You can see that the coordinates of the image are minus 2, 3. So you can see that the x value of the point changes sign, but the y value stays put. The y value is still 3. Now let's look at symmetry in the origin. That's what this O stands for. So the origin has coordinates 0, 0. Now we're talking about the image of the point 2, 3 under central symmetry in the origin. Central symmetry means we're mapping the point 2, 3 through a point, not through a line. Axial symmetry is through a line. The first two examples were examples of axial symmetry, where we got the image through axes or lines. So to do this geometrically, you can imagine drawing a line from the point 2, 3 to the origin, extending this line through the origin and going out the same distance on the other side and reading off the coordinates of the image. That's quite easy to do. You see that we go down 3 units and we go 2 units to the left. So we do the same with the origin. We bring the origin down 3 units and bring it across to 2 units to the left. So we end up here. We just read off the coordinates of this point. We can see that the coordinates are minus 2, minus 3. So you can see that both the x and y values change sign when we map a point through the origin. Now let's get the image of 2, 3 under axial symmetry in the line x equals 4. Now in the last video I explained horizontal and vertical lines. The equation of a vertical line is x equals a constant. In this case the constant is 4. So x equals 4 is this line here. It's a vertical line through 4. It's got vertical lines have a very simple form, x equals a constant, because all the points on this line have x values that are 4. So x equals 4 fully specifies this line. So basically we want to get the image of 2, 3 under axial symmetry in this line. So we just map it through right angles and we go out the same distance on the other side. So we end up here. See, 2 units on this side and another 2 units. So we can just read off the coordinates of this point. We can see that the coordinates of this point are 6, 3. Let's look at central symmetry in the point 3, minus 2. Let's see where 3 minus 2 is. It's this point here. Okay, there are 2 ways we can do this problem. We can use the diagram or we can do it without a diagram. So first off, I will do this with a diagram. So what we want to do basically is map the point 2, 3 through this point 3 minus 2. We're actually going to end up down here. So we want this distance to be the same as this distance. Now the way you can do this is get the vertical and horizontal distances between the 2 points. So the vertical distance is this distance here. See what that is? Well, we can just see from the diagram that this is 5 units. The horizontal distance between them is 1 unit. And then basically we just reproduce this triangle we go down 5 units, and we go across 1 unit. This point here is the image. We just read off the coordinates of this point. So you can see that we're down on -7 here. So this point here has coordinates 4, -7. We could do this question without a diagram. We could just look at the differences in the x values and the y values. So we want to map the point 2, 3 through the point 3, -2. So 3, -2 is the center of this symmetry. And we want to see what we get. Well, we know from the diagram we get 4, -7. So let's see how this works. We look at the x values. We take this x value and subtract this one here. 3 -2 gives us 1. And because we get +1 here, we take this x value and add 1 to it. So we get 3 + 1 is 4. Now we look at the y values. So we see what we have to add on to 3 to get -2. To find that out, we could just take -2 and subtract 3. -2 minus 3 is -5. See, that's the distance we went down. We have to subtract 5. So now we take 5 from -2. So we work out -2 minus 5, which is -7. Exactly what we got in the picture. Finally, we want to find the image of 2, 3 under the translation 5 minus 2 goes to 2 minus 3. So let's just plot this translation. 5 minus 2 is this point here. 2 minus 3 is here. So the tail of the translation is at 5 minus 2. The head is at 2 minus 3. So we can show a translation like this, like an arrow. This is also known as a vector. Okay, we want the image of 2, 3 under this translation. So that means we want to move the point 2, 3 in the same direction as this translation and the same distance as the length of this translation. Well, we can do that by looking at the squares. We see here that for the translation, the vertical distance between the endpoints is 1 and the horizontal distance is 3. So we have to go down 1 and across 3. So we're here. This point has coordinates -1, 2. So -1, 2 is the answer. Now let's do this problem without using a diagram. So our translation is 5 minus 2 goes to 2 minus 3, and we want to get the image of the point 2, 3. So we write 2, 3 down underneath the translation, and we have to work out what this point is. So like before, for the central symmetry case, we look at differences. So what do we have to add or subtract to 5 to get 2? Well, the answer is 2 minus 5, which is -3. 5 minus 3 is 2. So we do the same to the x value here. We work out 2 minus 3, that gives us -1. Now we look at the y values. What do we have to add or subtract to -2 to get -3? Well, we look at -3 minus -2. -3 plus 2 is -1. So -2 minus 1 is -3. And we have to take the 3 and subtract 1. 3 minus 1 gives us 2, just like in the picture.